Welcome, everybody. In this video, I want to look at some examples of solving quadratic equations in the real world. So we'll do some problem solving. Remember, quadratic equations are equations whose highest power is a 2 or a square. So here's one example, and this actually is a pretty common application of quadratics, would be any sort of falling or thrown objects. So let's say an object is dropped from the roof of a 256-foot tall building. Neglecting air resistance, the height h in feet of the object above the ground after t seconds is given by the following equation. H equals negative 16 t squared plus 256. Find how long it takes the object to hit the ground. So, what's happening here is, you have some sort of building. All right, so here's my building. And there's going to be an object on top of the building that's going to just be dropped, right? So it's just going to be kind of just dropped right off of it, and it's going to obviously head towards the ground, right? So our goal here is to figure out, well, how long does the object take to actually hit the ground? So think about what that means. If we're on the ground, the height of that object then would be 0 feet, right? It'd be 0 feet off the ground. So our h would be 0 here. So what we're doing is we're actually solving for h, in our equation, h equals negative 16 t squared plus 256, is we're solving when h is 0. So when is that height equal to 0? All right, so the first thing I'm going to do here is I am going to solve this by factoring. Again, that is one of our main strategies here. And I am going to go ahead and start by factoring out the 16 in both of these pieces. I'm also going to factor out the negative as well. Again, I tend to like my leading term to be positive, so I'm going to take a negative 16 out there. If you do 256 divided by negative 16, you get negative 16 again. So that would be the answer here. Now I can keep factoring this a little bit more, right? So I still see a square left over, and t squared minus 16 can actually be factored into t minus 4 and t plus 4. We have a difference of 2 squares here, so it factors as follows. Now I have equal to 0, and I can solve by setting each of these pieces equal to 0 and see what happens. Now, in the first case, negative 16 equals 0 doesn't make sense, right? There's really nothing for us to solve there, and it's false. So I'm going to get rid of that one. Here, I'm going to go ahead and add 4 to both sides. And here, I'm going to go ahead and subtract 4 from both sides. Now, I do have 2 answers that work in the equation here. However, you have to think more about context in this case. If an object is being dropped off a building, and we're trying to figure out how long it takes the object to hit the ground. Now, remember, t, we're also told, is in seconds, right? So t was in seconds here. Then that means that this represents 4 seconds and negative 4 seconds. Now, negative 4 doesn't make sense in this example, right? Like, why would it take negative 4 seconds to hit the ground? That doesn't make sense. So our only answer here that actually really does make sense in this context is going to be the positive 4. So we actually have one solution here of 4 seconds. We're actually going to throw out the other answer. Even though mathematically it does work in the equation, it just doesn't make sense when answering this question. So the only real viable answer in this case would be 4. So 4 seconds it would take for that object to hit the ground. All right, next example. And again, I do have our problems already written out because they do take some time to write. So don't forget, you can always pause and start this video as many times as you need to in order to get set up. Now here we don't have the equation already given, we're going to have to find it. So think back to some strategies you have for problem solving. So the first thing you're going to want to do is read through the problem as many times as you need to in order to understand it. We've talked about also writing the goal to help us define our variable, and then of course looking through and trying to set up that equation on our own. So reading through, he says the square of a number plus 3 times the number is 70. And here's our goal. Our goal is to find the number here. So I'm going to let x be the number, right? There's not really much context. So I'm just gonna let x be my variable here. You could use n for number if you like. And I'm gonna try to set up an equation. So I see the square of a number. So the square of a number, that would be x squared plus 3 times the number. So I have x squared plus 3 times the number would be 3x. And then I see is for equals 70. So again, you may need to read through this equation a few times in order to have it set up correctly. You really just want to take your time here as you're going through. Again, I like to always define my goal so that I can help focus my what I'm looking for and define my variable, and then I can use that variable to write the equation. Once you have it set up, we're going to go ahead and solve. Now, for our purposes for quadratics, we're going to try factoring. So we're going to bring this 70 to the other side. And I have x squared plus 3x minus 70 equals 0. I don't see anything I can factor out overall. There's no common factor here. So I'm just going to have to start by factoring. And again, you can use trial and error, or you can use factoring by grouping. That's fine as well. If I use trial and error, the x squared has to be x and x. Now that 70, you have lots of options there, but the one that works to get the 3 in the middle is positive 10 and minus 7. There we go. That will give you that minus 70, but also give you that 3x in the middle. And then once you have that, we're going to go ahead and set each factor equal to 0 and solve. Now I'm going to go ahead and write my answers over here because I'm running out of room. So I have x equals negative 10, and I also have x equals 7. Now, if I think about this, it doesn't say anything that my number has to be positive or negative or anything like that. So these both seem to be fine. If I wanted to check them both, I could as well. So remember, we don't have a perfect check here, but we can always plug it back in and make sure it works. So let's check this through the wording. Negative 10 squared, so the square of a number. So I'd have negative 10 squared plus 3 times negative 10. Is that actually equal to 70? Well, negative 10 squared would be 100. And then 3 times 10 is negative 30. So yep, that does work out. If I try the 7, I would have 7 squared plus 3 times 7. Is that 70? Well, 7 squared is 49. And 3 times 7 is 21. So that actually checks out as well. And again, I don't have a context here that says it has to be positive or anything different. So both of these in this case are still viable answers, negative 10 and 7. All right, let's bring in a little bit of geometry here. So it says the height of a triangular sail is 7 meters less than twice the height of the base. Let me change that here. It should be length of the base. That makes more sense. Bases don't really have height. Twice the length of the base. If the sail has an area of 30 square meters, find the length of its base and the height. So this is the one that, we may want to draw a picture here to go around with it as well. So if I have a ship and I have some sort of triangular sail, right? Let's say, this is going to be my bad ship, but let's say here's my ship. The height of that triangular sail is right here. This is my height. And then down below, I would have my base. Okay. So let's see. The height of a triangular sail is 2 meters less than twice the length of the base. If the sail has an area of 30 square meters, find the length of its base and the height. So I'm going to start with my goal here. So our goal here is to find the length of the base and the height. So there's 2 things I'm looking for here. I'm looking for the base, and I'm also looking for the height. Now, if I read back through again, I do see that it says the height is 2 meters less than twice the length of the base. So I'm noticing that the height is given in terms of the base, right? So the height is 2 meters less than twice the base. So this is pointing me to the fact that I should let the base be my variable, and let's write height in terms of that. Now, if you want to use b for base here, you can. I'm just going to use x and keep it simple. And now let's just be a little bit careful. 2 meters less than, so that than is going to change the order of the subtraction, twice the base. So twice the base is 2x, but then I'm subtracting out the 2 meters there. And again, I'm just using m for meters. It's not a variable, it's just my units. The other thing I know is I know the area is 30 square meters. Now, if you don't remember, the area of a triangle is 1/2 the base times the height. So I'm going to use that to help me set up my equation here. So my area is 30, 1/2. My base is x, and the height is going to be 2x minus 2. So I'm going to use this equation to get going, and I'm going to clean this up first and multiply everything out. So first, 1/2 x, 1 times x is x. So I'm just going to write this as x over 2 just to make it a little bit easier to read. And then I'm going to go ahead and distribute this through. Now, if you can do this in your head, that's great. If you can't, though, write it out. So you have x over 2 times 2x minus x over 2 times 2. I'm going to just move over here so I have more space. What you're going to notice is that the 2 here will cancel, and I'm left with x times x, which is x squared. And again, the 2 here also happens to cancel, so I have a minus x in this case. So at this point, I'm looking at my equation, 30 equals x squared minus x. Now I'm going to bring the 30 to the other side so that I can get one side equal to 0, because again, in this video, the strategy that we're using is factoring for solving. And then I can go ahead and I can start factoring. So I would have x and x, and 6 and 5, minus 6 and plus 5 would be the combination that works here. And again, please remember that's already assumed you know how to factor. So there's a lot of work that goes in between here, either using trial and error or using the grouping method. So if you need to pause the video and do that piece out on your own first before proceeding, please do. And then once you're ready, you would set each factor equal to 0. Now, my two answers that I'm getting are x equals 6 and x equals -5. Now, first of all, remember, what is x? X is our base. And also everything is in meters, right? If you read back through, it's all meters. So it would be 6 meters and -5 meters. Now, pause for a second here. I can't have a base of a triangle that's -5 meters. That does not make sense. So even though mathematically it works, it just doesn't make sense in the context of this problem. So that is not a viable answer. It has to be 6. That's the answer I'm looking for. So the base is going to be 6 meters. And then to find the height, what I'll do is I'll plug that 6 back into my original setup. So 2 times 6 minus 2 gives me 12 minus 2, which is 10. So for this particular triangle, let me see if I can just kind of get this a little bit clearer on the screen here. Our base, so that bottom there is going to be 6 meters, and our height is going to be 10 meters in this case. So that is the only viable answer. We have to throw the negative out here. So you just want to be really careful once you get into word problems. Even though things work mathematically, it may not be so helpful if it doesn't make sense in the context. So far we've seen a couple examples where, although we have two answers that work mathematically, we've had to throw some of them out because they just don't make sense. So our height here is 10 meters and our base is 6 meters. The last thing I want to remind you guys is I know it takes extra work in the beginning to do things like write out your goal and get organized, but I really think it's worth it because at the end of the problem, when I get an answer like 6, I don't have to go back and think, well, what on earth does 6 mean? I know because I've already written down that x represents the base. So 6 must be the base here. And then I can plug it into my expression for the height. So if I take some extra time at the beginning and get set up, think about the goal, write out your variables, write out what you're trying to find and organize those pieces there. It really makes the end of the problem much easier. And it will also make it easier when you go back to review your notes and study, or if you're looking at a question, you can't figure out what you did wrong on the homework. If you're more organized, again, it really does save you time in the long run. So I know it's hard to train ourselves to take these little bit of, these extra steps at the beginning, but I really think in the long run, it's going to end up saving you time because it just makes the rest of the problem easier to finish and then easier to study later on.